U substitution in this problem is unbelievable. Yeah. So basically, this problem looks somehow complicated. Yeah. But after a very tricky U substitution, this problem will be a lot easier. And basically, the problem credit goes to Nico Jeharen 6566, who proposed this problem in the comment section. Now let's solve this problem. Okay. So basically, our U substitution goes something like this. What we will do is we will basically let y equals to 2 minus x by 1 plus x. Now the numerator basically helps us to reflect the limits of integral. The denominator basically helps to preserve the original integral. Yeah, and the integral is basically made in a way such that this will work, and let's see how. So basically, if we have this, now let us try to take this function as x in terms of y, then we can take dx. For that we will just multiply y plus yx is equals to 2 minus x. That gives us yx plus x equals to 2 minus y. Yeah, and then x times y plus 1 is equals to 2 minus y, and then x equals to 2 minus y by 1 plus y. You can notice that both of them are actually same. Yeah. Now let's try to find dx. Okay, so we need to differentiate that b and then derivative of u minus u and then derivative of b by b square and then dy. Yeah, so dx is equals to, this is minus 1 minus y, yeah, and then minus 2 plus y by 1 plus y whole square dy, and so dx is equals to minus 3 by 1 plus y whole square and then dy. Okay, so now we have found dx in terms of y. Yeah, now let's try to see like what this changes to when you make the substitution. Okay, so when you make the substitution y x as 2 minus y by 1 plus y, we get 2 minus y by 1 plus y whole square minus 2 minus y by 1 plus y plus 1. So our LCM will be 1 plus y whole square. Yeah, over here this is 4 minus 4y plus y square minus, this is 2 minus y 1 plus y, and then plus we have 1 plus y whole square. Yeah, now let's try to expand these expressions and let's see what do we get. 4 minus 4y plus y square minus, this is 2 minus 2y plus y square. Yeah, if you multiply that. Yeah, and then we have 1 plus 2y plus y square by 1 plus y square. These stuffs might seem a bit complicated, but the problem is made in a way that this should actually work. So the problem itself has been made with a lot of attention, so that's why all of these stuffs will at last like get into a pretty nice form. Now this is we can cancel the 2y, and then we have 3y square. Now this is minus 4y plus y, that's minus 3y, and then 4 minus 2 plus 1, that's plus 3. But now you might have already noticed that the denominators over here and here are same. Yeah, and then 3 common out, y square minus y plus 1 by 1 plus y whole square. Okay, so now we have made a lot of progress, and now let's see in the progress that we have made. So basically now let's make the substitution. So if I make this substitution, so basically the limits will just reflect, I guess. Yeah, so here's 2 minus 0 by 1 plus 0, that's just 2. Over here 2 minus 2 is just 0. Yeah, and over here we have ln of 1 plus, now x is just 2 minus y by 1 plus y by, now we know that this converts to 3 times y square minus 1, y square minus y plus 1 by 1 plus y whole square. Yeah, and now what does dx goes to? Minus 3 by 1 plus y square dy. Yeah, minus 3 by 1 plus y whole square dy. Okay, so now let us use the negative sign to reflect the integral. Yeah, that gives us integral from 0 to 2, and this also cancel out, and then 3 also cancel out. Yeah, and now if we add 1 plus y plus 2 minus y, and that's just ln of 3 by y square minus y plus 1, and then minus ln 1 plus y by y square minus y plus 1 dy. Integral was from 0 to 2 again. Okay, now we can see that the integral that is in the problem and the integral that we have come across are the same. That means if we let this integral as I, the integral over here will also be I. Yeah, so that's why we have I equals to, okay, but just to wait a second. Okay, fine, I think it's going fine. Yeah, now I equals to integral from 0 to 2 ln 3 by y square minus y plus 1 dy minus I, this is also I. So we have 2I equals to this integral. Now let's complete the square in this integral. 0 to 2 ln 3 by, this is y minus 1 by 2 whole square. Yeah, and then plus root 3 by 2 whole square. Yeah, so now this integral would be this integral would be ln 3 times, this is just the a square plus x square, that's of 10. Yeah, so 1 by a tan inverse x by a, and since they have same denominator we can write this as 2i minus 1 by root 3. Yeah, and this is from 0 to 2. Yeah, now I equals to ln 3 by 2 times 2 by root 3 times, this is, when it's 2 we have tan inverse of 3 by root 3. Tan inverse root 3 is just pi by 3 minus, now when it's 0 it's tan inverse minus 1 by root 3, so that's minus pi by 6. Yeah, now we have this cancels out. I equals to ln 3 by root 3, and this is pi by 3 plus pi by 6, that is 60 plus 30 is 90, which is pi by 2. That's why we have pi ln 3 by 2 root 3 as the answer of this integral, and that's the correct answer. You can check in the Wolfram Alpha, I've already done that. Yeah, so that's the answer. Like, hope you enjoyed the video, and hope you also got idea about like how to guess this expression. But yeah, like there might be better ways about how to guess this expression than I have told. If yes, please share it in the comment section. And yeah, I hope you enjoyed this wonderful new substitution and the solution. Thanks for watching. Look forward to seeing in the upcoming videos too.